Hi everyone, Paul from Litebox Architecture. So today's video I wanted to talk about structural engineering and discuss what a structural engineer does and how they provide value for your project. So today I've got a guest on, and that's Jason from Structural Calculations. He's our engineer that we work alongside on the majority of our projects, and thought it'd be good today to get him in to chat about structural engineering and give you guys a little bit more information on what to think about. So, Jason, if you want to explain to people a bit of background for you and what you do for...
Yeah, thanks Paul. I'm a structural engineer. I work at my company, Structural Calculations Ltd. We do mainly residential projects, loft conversions, extensions, new builds, that kind of thing. We do a lot around this area, but all over the country. We do a lot of work with Paul as well.
Yeah. Okay, so first things first, what does a structural engineer do?
Well, we provide advice on the material selection for your build. So whether you want to suspend a large sort of weight above the ground floor, then maybe you need a beam, or it's usually when something's unusual or something's out of the ordinary with the build, then you might need some specialist advice from a structural engineer.
So anything to do with structures, foundations, beams, knocking walls out, anything like that is what we need you guys for.
Yeah.
And obviously you provide most of the information when we're working on drawings and details, and we'll liaise with you for all the info that we need in order to progress that and then ultimately submit it to building control and for the contractor.
Exactly right, yes.
So, for clients out there, do they need a structural engineer for their extension?
Possibly, possibly not. It depends on the build. Historically, we like to live in sort of small rooms with each sort of area divided up, but now the preference is open plan living.
Yeah, it's becoming more popular.
Yeah. So you have like your kitchen, diner, open into your living space, but at the same time on the first floor, we still like walls between the bedrooms and the bathrooms, and we're not open plan upstairs.
So we're having to put beams in then to support those walls up above.
Exactly. So you've got all that weight and walls upstairs, but on the ground floor you want it open. So we've got to distribute that weight out to certain areas, which means you get beam arrangements and concentration loads on the external walls, which is where a structural engineer comes in.
Okay, and then equally if the client wants to, for instance, extend out to the rear of property, whether that's two-storey or single-storey, that they want to knock out that external wall.
Exactly. It's quite often you want to take out the back wall of the house and create a big open plan that goes out into the rear extension, but you've got the main back wall of the house then suspended above your sort of open plan area, which is supporting possibly floor joists for the first floor, the roof, all that kind of thing. So
what's your role in that project then? So for us, we would be looking at designing and laying out the space for the client, how the sort of look and the feel of the building's going to be, and how it links to the existing space. But your role would be more...
So we'll take that design and we'll have to make the building work structurally. So we'll take the loads from the roof all the way down to the foundation, and we'll have to make sure that resolves structurally. And all that load is transferred safely and that the building is stable.
Yeah.
So we try to make your design work, whether that means including steel beams or steel columns or masonry piers or sometimes with timber or
so in a way you're putting the bare bones of the carcass together of how it's going to be structurally sound, and as you always say, we put the pretty bit on the inside.
Exactly.
So yeah. So why do I need a structural engineer for foundations? So if I set a bit of a scenario that the building work started, the contractor's on site, he's got the digger there, he's just dug a hole in the ground, and the ground probably doesn't look quite exactly as he thought it was going to be, whether that's made up ground or that's a different soil or something. So we would then be calling you guys. So what's your sort of role there as a structural engineer with regards to foundations?
Yeah, exactly right. We're not needed on every project necessarily. I mean, if you've got good ground and you haven't got drainage issues, you haven't got concentrations of load, you haven't got trees nearby, then you probably won't need us. But if all the planets don't align, then you're probably going to need an engineer to come up with a solution for those problems.
Yeah. So, for instance, if you've got with foundations, so if you've got made up ground, or the majority is probably the areas we work in, we've got probably pretty good clay foundations. But what types of soil would you be considering that probably wouldn't be good for a normal foundation?
It depends. If you've got trees nearby, then clay's not good, because clay can shrink and heave a lot with moisture content.
Yeah.
So you might have to go deeper on your foundations. If you've got well-drained soil, then you wouldn't have an issue with that. Obviously you need to watch out for the water table as well in certain areas. Made ground is always an issue, because it basically means like building waste has been sort of piled up somewhere.
So you've got this big layer on the top of that's been made up, and actually the decent ground is quite a lot lower for.
Yeah, if you've got a lot of voids in this made ground, then over time that can consolidate, and you can end up with voids below your foundation.
Which would mean then ultimately the building that you build is going to either move, and it's going to start to pull away from the existing.
There's various solutions that we can offer, such as like raft foundations, which spread the load over an area, piled foundations, which take the load down to a good strata, and then we put a ground beam above those. Obviously we need to do bridging over drainage and stuff like that. So there's lots of things we can offer, but they all need designing by an engineer, because they're not so straightforward.
So things like, for instance, you mentioned piled foundations, which is in essence is, I'll keep things very simple, is driving a big concrete or metal pile into the ground to go to the good ground below the not so good ground.
So you'll have a load of these pins around your build, and then you create a reinforced concrete ground beam around the top of those, which you then build the building.
Yeah. And then you've got obviously deep strip foundations, where the contractor can dig out to sort of 2.5 meters to dig down through whatever the ground is to put a deeper strip foundation in.
It's usually to get down to the level of the bottom of nearby drainage, or get below the effect of a tree if there's a problem tree nearby. And
then obviously a raft foundation, where in essence they kind of create a metal framework that they then infill with concrete, that then the slab floats on the top of the ground that spreads all the load.
That's right, yeah. So they're designed to move. They're reinforced concrete that can move as a whole, and they can cope with voids opening up. But they also spread the area over the slab portion. They spread the weight over the slab portion of whereas a traditional foundation, all the load is around the perimeter, and the slab is independent.
But obviously when you're looking at different foundations like that, there is going to be increased cost. So the simplest way is obviously to put in a normal traditional strip foundation, but sometimes that isn't possible. So therefore there are other solutions, but obviously they are going to cost more because they're more engineered. And obviously that's when you guys come in, because you need to engineer those foundations and design all the layouts and how that's going to work, and whether that's got any kind of spreading the loads or cantilevers or taking the loads to a deeper.
Exactly.
So my next question is, can the architect or designer deal with the structural engineer, and can he provide all the structural calculations and liaise with yourself on the client's behalf?
Often the case,
Which obviously for us, we do this quite often. We're well versed in it, so we'll provide all the drawings and details. We agree with the client what the price is going to be, and then we will liaise together, because it's much easier for us to liaise and discuss the more technical details that potentially the client might not understand those details. So it's much easier for us to pick the phone up, have a chat, go through some design ideas with either yourself or your team, to get to a solution of whatever we need for that particular job. So in essence, yes, as we can deal with that on the client's behalf, and obviously engage and deal with the structural engineer as well. So my next question is, if we can explain to clients, the difference between what is a load-bearing wall and what is a non-load bearing wall, because this seems to be a technical term that obviously we use, but obviously clients don't understand necessarily what that is.
Yeah, I mean it's not as sort of technical as you might think, or as some people think. It's, I mean, the clue's in the name, I suppose. Is it bearing a load? If yes, then it's a load-bearing wall. So, I mean, it could be built off a slab. It doesn't necessarily need a foundation under it, but usually a load-bearing wall would have a foundation under it.
Yeah.
But there's also buttressing walls. So there isn't just load-bearing walls that take vertical load. There's also walls that buttress the external walls.
Right.
So there's two considerations there, really.
Okay.
When thinking about removing a wall.
So I guess that leads on to my next question of how's the best way to check whether that wall is a load-bearing wall or it's a non-load-bearing wall? Now, I think probably traditionally people may think that, you know, if it's a stud wall, it's not load-bearing, which, you know, probably may be the case in, you know, a good percentage of the time, but a timber or stud wall can be a load-bearing wall as well.
It, yeah, I mean, we design structural stud walls all the time, so you can put load down them. More often than not, they are just infill walls.
Yes.
But yeah, you're right. Yeah, you can't be sure just because it's a stud wall. Obviously, the way to find out if it is load bearing is to somehow get above the wall. So is there another wall upstairs directly above it? You can have a look above the ceiling. Are the floor joists resting on it? Or you can come in from above and look below the floor. Are the floor joists resting on it from there? You've also got to be careful as well, because somewhere along the wall there might be another beam. So the floor joists might be going parallel to the wall,
right,
but they might run into a steel beam that then sits on the wall. So
right,
you have to be sure about the full length of the wall as
so
well.
I guess then, following on from that, is obviously I don't want anybody out there kind of, you know, knocking walls out thinking that they're not load bearing, that they've listened to us and gone, oh, it's okay, you know, we've said we can knock it out. So you know, really the best way is to potentially always check with either your architect, designer, speak to the builder, or ultimately is get the structural engineer out to check whatever it is that you need to knock out to make sure that it's safe. Obviously, if you do knock through a load-bearing wall that isn't supported, then it can be catastrophic, that you can end up with walls and joists and different things all collapsing, or even at worst case scenario is the building collapsing. And obviously I wouldn't want any of our clients or anybody out there watching this for that to happen. So best thing to do is always check with your structural engineer beforehand. So
that's right, yeah. I mean, there are other considerations about, you know, what masonry is left either end. So it might not have weight directly above it, but there might be load spread through it from a perpendicular wall.
Right.
Yeah.
So I'm going to talk to you then about one of the common questions that I always hear on a building site from the contractors, you know, sometimes clients, but you know, majority of the time it's the builder or the contractor, is, you know, the engineers detailed the drawings, he specified the beams, but he's over-calculated them. You know, they're way too big. Why do they need to be this big? They're really heavy. You know, he hasn't got to get them up into the space. Certainly when it's a loft conversion, he's got to get them up 2-3 floors. Yeah. And I hear that an awful lot. So what's your comments on that?
Yeah, I hear that a lot. And some builders do say it. I mean, some do understand that it's not just about the strength of the beam and what load it would take to break. It's also about the flex, because, you know, in modern buildings we've got plaster finishes everywhere which are very brittle. So if the beam flexes too much, you're going to cause cracking. Also the wall above the beam will get cracks in it, because again, masonry is very brittle. So with the British standard calculations that we've got to apply on a longer span, say like an 8-metre long beam, it's much more critical, the deflection check. So we've got to limit the curvature of the beam. The beam can only deflect or bend by a certain amount in the middle in order to prevent the cracks occurring in the plaster or the masonry above. So far before the beam has reached its potential for bending strength, you know, we have to apply a limit on how much it's flexing. Yeah,
which, you know, in essence is we're talking about the beam kind of doing this, that it's bending in the middle, as well as whatever it's supporting up above.
Yeah. I mean, you don't want to have your new fancy master bedroom done. Bring all your friends round and bring them all into the room to show them. And the beam flex is just that little bit. And when you go back downstairs, there's big cracks in your plaster. Or whenever you get snow on the roof, or you know. So we design it for the worst case load situation, and then we make sure that it won't flex enough in that situation to cause any cracking.
So the beams that you work out are, all of this is calculated exactly to fit. You don't over specify beams. You're trying to get the beams the most cost effective way for the client as you can.
There are safety standards, safety values built into British standards, which we have to apply. So nothing is designed anyway on its limit at 99% of its capacity. Everything's got its safety factors built in, but we will work to those safety factors. We don't over specify by a long way. We design to the standard and what the standard says.
So basically, the builders have just got to get on with it and get it up there.
But with heavy beams, we can splice them into pieces. So if you've got an 8 metre long beam and you need to get it up into a loft, we can splice that into 3 pieces. So you can take them up in sections and then bolt them back together in position. Or we could splice it into 6 pieces if they wanted. It comes down to cost.
I know on extensions these days that the builders they can hire genies. So genies being lifts or mechanical lifts that you can use. So you can a bit like a sort of static forklift truck, and they can wind them up to get the beams into place. And I've seen more recently with the builders is that they'll hire a small crane for the day, and although that sounds excessive, the cost of it and the time that it saves, that the crane will just lift up the beam in one piece. They've saved on splicing, sort of splicing details perhaps with yourself. They've saved on the actual fabrication of the beams, being chopped and cut, ready for bolting together.
Small crane hire, you can do half a day. It isn't a vast amount more than hiring a genie for a week. So,
so that works. So one of the other questions is that, does your steel beam need fire protection? Now, I guess this is something probably I could answer, but the fact that yes, your steel beam does need fire protection. It's part of the building regulations, and you will need to provide, if it's a domestic property, so this is only domestic, not commercial. If it's domestic property, it's going to need at least 30 minutes minimum fire protection. And there's 2 ways that you can achieve that. That is either encasing the steel beam with a 𝗡𝗲𝗏𝗱 12.5mm fire line board, or you can use, if you want to leave beams exposed, which I've seen a lot more in properties, and actually in my own property I've got the beam that's exposed, you can use a 30-minute intermescent paint. So you would paint the beam first of all with the fire protection, and then you can paint over the top of that with for instance, a colour, whether that's a grey, a black, a blue, a yellow, whatever colour you like. And it actually does give another dimension to the building, because you're leaving some of the fabric exposed, which I find myself, I think it works really well. So, but yes, so ultimately you do need fire protection for your beams. So, does a structural engineer need to be qualified, and does he need to have insurances in place?
Yes, he would need a degree level qualification in civil or structural engineering as a minimum. You need someone with experience as well, because engineering is such a broad field that we all can specialise in very different areas. So if you want an engineer for a domestic residential project, you want someone with experience in that field, and a number of years experience in that field.
So somebody like yourself that does that sort of work.
Yeah, definitely. And insurances as well. So you need you need a product liability, professional indemnity, and if they're going out to site, public liability. Have I said that one?
That's exactly the same as us. So even for us, from the design point of view, we still need professional indemnity, public liability, products liability. All those things just to tick the boxes.
And you want to make sure the level of cover is enough for the project that you're getting done. So if you've got a £2 million house, make sure that you've got £2 million worth of cover from your engineer.
I guess then that, and the same as how we work, it differentiates then between whether the particular person that you need for the job, and I guess is selecting the right person for the job. So it's, you know, if it's residential project, then you need somebody that works with residential projects from an engineering perspective. Or if it's commercial works, that you've got somebody that deals with commercial works. So yeah, it's about selecting the right person for the job, and then having their insurances in place, and having experience, in my eyes, goes a long way. Yes, you need to be qualified, but also that experience is you know, you can really use that, especially when you get difficult projects, or you really need to come up with an engineered solution to get over a particular problem.
That's it, yeah.
So one of the things that I get asked is, you know, does the structural calculations that you provide, do building control need to see those calculations? Why do building control need structural calculations?
Yeah, so again, it's whenever you're doing something out of the ordinary, or you've got large concentrations of load. Ultimately, the building inspector wants to make sure the building is safe for the current inhabitants and anyone else going forward.
And conforms to Part A of the building regulations.
Yeah, exactly. So they'll get specialists in for different elements, like they'll get an electrician in to provide a certificate against the electrical installation.
Yeah.
So, you know, a building inspector doesn't know all areas of building, so he relies on the professional services that others provide in order to make sure everything is ticked off, safe and suitable.
Everything conforms to the building regulations. Yeah. Everybody's professional and have the right skills in order to provide that information that they need.
Yeah.
Obviously, with you know, majority of the jobs that we work on, projects, you know, we for our clients, we need to submit drawings, details, specifications to building control in order to get a building control approval for the client to start the works, and then ultimately building control will sign the job off at the end with a completion certificate. But part of that is that we also need structural calculations that we submit to building control so they can sign that off as part of the job as well. Okay, so my final question, and the burning question that everybody wants to know, is how much does it cost to engage a structural engineer?
Not as much as an architect. How long's a piece of string? It's a difficult one. Could be anything from, I mean, typically, yeah, ranges from £300 to £2,000. It depends on the size of the project.
So if we relate this back to then, say, domestic style projects, you know, is that a sort of, is there an average that people will pay, say, per beam, or is there a sort of average approximate cost that people will pay, say, for instance, for single stories, 2 stories, loft conversions, that sort of thing? I mean, I know obviously that, you know, jobs can be very complex, and even the smallest of jobs can have a lot more complexity to it and need a lot more engineering work, and so you can't necessarily tie the cost to that.
Yeah.
But on average, what would people expect to pay for structure?
Yeah, I mean, it's charged per calculation is how we work it out, and then so we'll look at the project and we'll look at how many beams or timber calculations or foundations that we need to design, and then we'll apply a rate to that. So, I mean, typically like a rear single story extension might be £300 to £500. Loft conversion might be 500 to 700.
Yeah. And again, depending on how complex it is, because you'll have jobs that will be potentially may go way above that if it's a really complex, job. I mean, I know that the building inspectors are now asking from us that where people are having large glazed openings in their extensions, you know, so for instance, single story with large roof lanterns or flat glazed roof lights, anything like that, that building inspectors are asking for the engineer then to calculate these things to make sure that the timbers are the correct size and weight, not just relying on Strada tables, but they want the calculations from the engineer, which obviously then is adding to the cost and adding to, you know, your cost, because you've got that extra bit as well that you've got to calculate. And I've seen this more often, but hopefully that gives you a good idea of what engineers' costs will be. But obviously, again, it's a good idea that if you've got drawings or details that you can give it to the engineer first of all to have a look at the job, to assess it, and then obviously give a price from there. Because
happy to price up anything that can send through.
It's not a one price fits all, as in
exactly,
essence. Okay, well, I hope everybody's really enjoyed today's video, and that's given you a bit more insight into what the structural engineer does and how they assist you on your project. If you've got a project in mind, then please get in touch. You can either pick up the phone and give us a call. You can get hold of us via our website. We've got our new online booking system that's now working at 𝗏𝗏𝗃𝗏𝗃𝗏𝗃.co.uk, or simply drop us an email at info@𝗏𝗏𝗃𝗏𝗃𝗏𝗃.co.uk. I will drop into the details below on this video all of Jason's details, so if anybody wants to get hold of Jason, they've got any structural calculations or any projects that they want him to have a look at, his details will be there for you guys to pick up and get in touch. Also, if you're enjoying the content and the videos that are going out, then please hit the subscribe button. Please like and share our YouTube videos. It just helps us to grow the channel and keep bringing out really good content for you guys to watch. Thanks for watching. See you on the next one.
Bye.